Here's the video for section 2.5, and this is going to be about a few more applications of solving right triangles. First of all, we need to talk about using bearings. There are two methods for doing this. In the first method, we're just given a single angle, such as 164 degrees. The way we figure the bearing in this case is that we start from due north and go around clockwise. Here are some examples of using method 1 for bearings. If we have a bearing of 32 degrees, that means we're going to start from due north and we're going to go clockwise 32 degrees. So that gets us to right here. The direction we'd be going would be this direction. If we have 164 degrees, again we're starting from due north and we're going around 164 degrees clockwise. That puts us somewhere between south and southeast. And last of all, if we have a bearing of 304 degrees, we're starting from due north, going around clockwise 304 degrees. That puts us a little bit past 270 degrees, which would be over here. We'd be going off in this direction. Here's an example where we're actually using the bearing to solve a problem. So in this one, we've got our two radar stations, A and B. It's a little bit confusing because it says they're on an east-west line. And to me, that would mean that A was east of B, but that's not actually how they meant it in this problem. Here's what the picture actually is. The A is meant to be to the west and the B is to the east. But they're 3.7 kilometers apart. And this radar station detects a plane at point C on a bearing of 61 degrees. Going 61 degrees clockwise, this is the direction that the plane is in. From station B, the bearing to the plane is 331 degrees. So down here, I'm starting from due north, going around 331 degrees. The idea is where these two intersect is where the plane would actually be. And what we're asked to find in this problem is the distance from A to C, so the distance from here to here. Right now, we don't really have any of these angles. We do have one side of this triangle, but we're trying to find this distance right here. To do that, we're going to have to figure out what some of these angles in the triangle are. Now we know that this is an east-west line, and this is due north. That means that this right here is a right angle. And we've got part of it already, 61 degrees. So this angle here would be the complementary angle to 61 degrees, and that would make it 29 degrees. 29 plus 61 adds up to 90. We can do the same with this angle over here. We know all the way around from here to here is 331 degrees. We also have a right angle right here. So there are a couple different ways we could do this. We could say that going from north all the way around to west would be 270 degrees, and we could subtract that from the 331 degrees, or we could see what angle would complete the circle, and then that angle would be complementary to this one. I just chose to do the 331 degrees minus the 270 degrees, which gives me 61 degrees. So that gives me this angle right here. Now I also want to see what angle C is, and we know we've got three angles in a triangle that have to add up to 180. We add these two together, guess what? We get 90 degrees. That means that this angle up here is also 90 degrees. Now we've got the three angles and we've got one side, so we should be able to use a trig relationship to find this other side that we're actually looking for. Now, since this picture is kind of messy, I'm going to redraw it over here. So here's my redrawn triangle. What I'm trying to find is the length from A to C. So I could just leave this as AC, or I could call it something else like X. Let's look at the 29-degree angle and see what these other two sides would give us for a trig relationship. So for the 29-degree angle, this side is actually the hypotenuse. That's a little bit harder to see in this picture, but remember this is the right angle over here. The hypotenuse is always across from the right angle. So this is the hypotenuse, and then this side over here is actually the adjacent side. My relationship that involves the adjacent and the hypotenuse is cosine. That tells me that the cosine of 29 degrees would be adjacent over hypotenuse, which would be x over 3.7. I just want to solve this for x, so I could multiply both sides by the 3.7. The 3.7 would cancel out on this side, and that would give me x. When I multiply this with my calculator, I get 3.236 approximately. Now I want to look at how many significant digits I have. I've got 2 in this value and 2 in this value. So I need to round this to 2 significant digits. That would make it rounded to the nearest tenth. So that's going to be the answer to my question for the distance from A to C. I want to put in the units. This distance was measured in kilometers, so that means this is going to be kilometers. So this would be 3.2 kilometers from point A to point C. Now we'll look at the other method for bearings. For this method, we start with either a north or south direction, and then we have an acute angle to show the direction either east or west from that line. If we have north 42 degrees east, that means we're starting at due north and we're going 42 degrees to the east. And that's why I labeled each of these with north, east, south, and west. So this would start north and it would go 42 degrees towards the east. So this would be our bearing right here, and that means we're going off in this direction. If we have south 40 degrees west, then we're starting at due south and we're going 40 degrees towards the west, which would be this direction. So here's our bearing right here. And this one, if we have north 52 degrees west, we're starting at due north and we're going 52 degrees this direction since we want to go towards the west. Now for each of these, we could also write them as bearing with method 1. This one would be the same as with method 1 because we're starting from due north and going clockwise. So this would also be 42 degrees with the other method. For this one, to do the other method, we'd start from due north and go all the way around to here. So that would give us 180 degrees to here plus another 40 degrees, which would be 220 degrees. For this one, to use method 1, we'd start from due north, go clockwise all the way around to here. To figure this out, we could go all the way around 360 degrees and then back up 52 degrees. So this would be 360 minus 52, which would give us 308 degrees. So this one would be the same as 308 degrees using method 1.